In this lesson, I'm going to show you how to graph the basic sine and cosine functions, and then we'll get into more complicated features of this about their characteristics, as well as being able to write the formula for a graph of a sine or cosine function that is given. All right, so let's start by just graphing the basic sine function here. I'm going to start with 0, plugging in 0 for x, then pi over 6, pi over 2, then 5 pi over 6 pi, then 7 pi over 6, 3 pi over 2, 11 pi over 6, and finally all the way around 2 pi. All right, so we know the sine of 0 is 0 from our quadrantals. The sine of pi over 6 is 1/2. Right, you can always use the unit circle that's just below us here. The sine of pi over 2 is going to be 1. The sine of 5 pi over 6 is positive 1/2. The sine of pi is going to be 0. The sine of 7 pi over 6 is negative 1/2, because we're in the third quadrant now. The sine of 3 pi over 2 is going to be negative 1. Sine of 11 pi over 6 is negative 1/2. And then sine of 2 pi is 0. So let's go ahead and plot these. A couple of things I want you to notice when you plot this. The tick marks are in radians, and each tick mark is actually pi over 6 radians. So you can count every time you see a tick mark, that's 1 pi over 6. All right, so the sine of 0 is 0. The sine of pi over 6, let's use this is 1, and this is 1/2. Okay, sine of pi over 6 is 1/2. All right, then we have 2 pi over 6, which we did not do. Then the sine of pi over 2 is 1. The sine of 5 pi over 6, which is actually going to skip that next one, is going to be positive 1/2. Sine of pi is 0. Sine of 7 pi over 6 is negative 1/2. Then we have the sine of 3 pi over 2 is negative 1. Then we have 11 pi over 6, which is almost there, which is negative 1/2. And then finally 2 pi is 0. So this is called a sine wave. And there it is. And that's called one full period of this sine wave. So it actually goes on forever in both directions. Excuse me. But for now, when we graph, I just want you to be able to do one full period of the graph. Okay? Let's do the same thing with cosine. All right, we're going to start with 0, but you're going to notice I'm going to use some different x values here because, for sine, the sine of pi over 6 is 1/2, but for cosine, the cosine of pi over 3 is 1/2. So to keep it nice and simple, then pi over 2. So a lot will be the same. Then we have, let's see, that's going to be 2 pi over 3 pi, 4 pi over 3, 3 pi over 2, 5 pi over 3, and then all the way around is 2 pi. All right, you'll notice actually the y values will be very similar. The cosine of 0, using the unit circle, is 1. Cosine of pi over 3 is 1/2. Cosine of pi over 2 is 0. Cosine of 2 pi over 3 is negative 1/2. Cosine of pi is going to be negative 1. Cosine of 4 pi over 3 is going to be negative 1/2. Cosine of 3 pi over 2 is going to be 0. Cosine of 5 pi over 3 is going to be positive 1/2. And then cosine of 2 pi is going to be 1. All right, so let's do the same thing. Remember, each of these are pi over 6. All right, so like the second one would be 2 pi over 6 or pi over 3, which we'll graph in a moment. All right, so 0, 1. Pi over 3 now, 1/2. Pi over 2, 0. Then we're going to have 2 pi over 3, which is going to be this next one. And then we have pi, which is negative 1. Then we have the one that's closest to the 3 pi over 2. Then 3 pi over 2 is 0. And then 5 pi over 3 is 1/2. Finished with cosine of 2 pi is 1. So this is what it looks like. Again, you'll kind of see that I know it definitely looks different, but if you were to go to Desmos or any graphing calculator and just type in cosine of x and type in the sine of x, yeah, they'd start in different places, but ultimately you would think they look very, very similar because they do look almost exactly the same. They just start in different spots. Okay, so there's the parent function for cosine. Again, it has the same period as sine. The period is 2 pi radians. That's how long it takes to complete a full cycle. All right, so there's a little blurb here about what the period is. You can count from, like with sine, a lot of people count from the beginning point, so the center, like the origin, to 2 pi. For cosine, we'll start at 0, 1, so the y-intercept, and count 2 pi radians. Your choice. For what types of, another characteristic of these functions is that the sine function, if you look at this one on the left, it has origin symmetry. So this has origin symmetry. So it is an odd function. So the sine of x is an odd function. Okay, and cosine of x has y-axis symmetry, right? It's going to be reflective across the y-axis. So this has y-axis symmetry. So the cosine of x is actually an even function. All right, so there's some more characteristics about those functions. And now I want to get into kind of the letters we're going to use and what they all mean and how we can use it to help us describe. Now, I want to just caution you, this is going to be a lot. It's going to feel like a lot. It definitely is a lot. It's going to take a long time, but we're going to take our time and make sure we feel comfortable with this. One other note is personally, right? I know this says it a little different. It doesn't matter if you follow the notes from the book or what I do, but I am going to be using essentially this, which is coming later. So if I notice that I can factor something out, I'm going to do that when I get a problem in the book, all right, or from the book. If I can factor out something that's in the parentheses, I'm going to do that. I think it's going to make it a little easier to see what our horizontal shift is. So let's kind of explain all this stuff. The letter A, all right, the letter A is going to give us the amplitude. The letter B is going to give us the period. The letter C over B, which don't get concerned by the fact that there's like a fraction there. Whatever is in the parentheses is going to be the horizontal shift. And the key thing, like we always have talked about since you were in algebra, is if it's inside the parentheses, you got to think opposite, okay? And then the letter D is going to be the vertical shift. Everything kind of stems from that. So let's first just try to find the period. So notice here, this is the function sine of, and I'm going to write pi over 6 in front of that x. All right, so I'm going to take that out, essentially. So my letter B, right, my letter B is pi over 6. So period, right, the period of a function is 2 pi divided by b. So I need to do 2 pi divided by pi over 6. And so that can be a little funky, right, with a compound fraction here. So let's do 2 pi over 1 divided by pi over 6. So now I think you'll see easier. 2 pi over 1 times the reciprocal, 6 over pi. Right, so you'll notice that the pi's will cross out, and we just have 2 times 6, which is 12 units. So the new period here is going to be 12 units. Okay, let's do this next one. All right, again, I'm going to write that divided by 3. I'm going to move that out to be 1/3 times x. So my letter B is 1/3. So I'm going to do period equals 2 pi divided by b, or 2 pi divided by 1/3. Just like before, I'm going to rewrite that as 2 pi over 1 divided by 1/3. And let's multiply by the reciprocal. And we can get our new period, which is going to be 2 pi times 3, which is 6 pi. So what I tell students each year is that when you're trying to find the period, when they've changed it, if your letter B has pi in it, right, like this one had a letter B which had pi in it, your period will not. If your letter B, like the second one, doesn't have pi in it, your period will have pi. All right, so there's always that back and forth between if I'm going to have pi in the period or if I'm not. All right, so just be aware of that. Okay, amplitude. Amplitude is how high or how low you're going to sketch for your graph from the midline, all right, or from the middle of the wave. All right, so this is related to the amplitude, and the amplitude is always the absolute value of that letter A. All right, so if there's a negative in front of it, all that's going to do is means that we're going to have a reflection, and I'll talk later about what happens when you have that negative. All right, so the absolute value of A is the amplitude. That's the distance from the top to the midline. So there's two ways to find it. You can just use A, or you can always do your highest point minus your lowest point and then cut it in half. All right, that will be the amplitude as well. So in this first one, all right, the absolute, let's just do A. A is -4. So the absolute value of A is +4. So the amplitude is 4. All right, and then it says, is it stretched or compressed vertically? So this is kind of going back to your days with, I always think of quadratics with this, but if you have a positive, when you take the absolute value, if your number is greater than 1, like this one is, this is going to be a stretch. Okay, let's do this next one. You've got A is 1/2. The absolute value of A is also 1/2, so the amplitude is 1/2. All right, and because this absolute value of A is between 0 and 1, this is what we call a compression. Okay, now let's get into, I kind of already mentioned this earlier. All right, we're going to get into the horizontal shift, all right, which in this book they call the phase shift. I'm not really going to talk much about phase shift. As I said, I'm going to be factoring out my anything that's in the parentheses. So I really just think of this as the horizontal shift. So here's a good example. Right here, it has f of x equals x minus pi over 4. I think opposite, so that's going to be a shift of pi over 4 units to the right. So that's actually this last blank here, pi over 4 units to the right. All right, same thing if I have minus pi, that's going to be pi, or should I say shift to the right by pi units. Okay, so if your C value is greater than 0, the graph shifts to the right. And if it's less than 0, so it end up being minus a negative or addition, it's going to shift to the left. And we're going to practice this a ton, guys. So don't worry if you're getting a little bit overwhelmed. Okay. Now the letter D, as I said, represents the vertical shift. All right, and this one is hopefully as straightforward as it can get. If it's plus a number, it's going to move everything up. If it's minus a number, it'll move everything down. If you can figure out the midline, all right, or the middle of the wave, that will tell you what letter D is every single time. So that's what I do. I do this step where I try to figure out what is the middle line of my wave, and that will give me my vertical shift. Okay, so let's do a quick few examples here. So we want to determine the horizontal shift in this first one, right? So if I notice I see x minus pi over 2, that's going to be pi over 2 units to the right. I didn't factor anything out because if you notice in front of this x, it was a 1. So I can't factor anything out there. So in terms of this one, I did not do any factoring. This next one, it has a +2, and we're trying to figure out the vertical shift. So my letter D is 2, so it's going to be 2 units up. All right, so that is it right now for the phase shift, which I call horizontal shift, and for the vertical shift. All right, so let's get into trying to put all this together. So let's do this example right here. So first thing I notice is I have something I can factor out. So I'm going to write y equals 1/2 cosine. I'm going to pull out the 1/3. All right, so x over 3 divided by 1/3 is actually going to be x. And then minus pi over 3 divided by 1/3 is going to be minus pi. All right, you can always multiply back in to check to make sure you factor correctly. All right, so from here, when I'm doing, it says the midline first. You'll notice it doesn't have any letter D. That's like +0. You don't need to write +0. But so if it doesn't have a vertical shift, your midline is just going to be the x-axis, or y equals 0. Okay, for the amplitude is the absolute value of A. So A is 1/2. The absolute value of A is also 1/2. So the amplitude is 1/2. Okay, let's do the period. So the period is 2 pi divided by b. So I'm going to do 2 pi divided by my letter b, which is always this number in front of, or I always think of like in between the cosine and the parentheses. All right, so that b is 1/3. So again, if I rewrite this as 2 pi over 1 divided by 1/3, that's the same as 2 pi over 1 times 3, which is going to be 6 pi. So that's my new period. All right, so you notice my period is bigger than 2 pi, which is the regular period. So in terms of when I sketch this, which I'm not going to, but if I were, it would take longer to do one full cycle. And let's do the phase shift, which I'm going to call the horizontal shift. All right, if you look inside the parentheses that I did, I have minus pi. So think opposite. The opposite of minus is positive. So this is going to be pi units to the right. All right, so let's try this one here. It says to determine the formula for the sine function in this figure. So the first thing I notice is that for sine, right, if I just do a quick little sketch over here, from the very first thing we did, the sine of x started at 0, 0. So sine of x started at 0, 0, right? And it went up, then it went back down, and then back up. So essentially, does it look like this? And the answer is yes, it does, right? Starting at this point, it goes up, it goes down, and it comes back. And it looks like for one full cycle, it's going from 0 to 2 pi. So I haven't changed anything in terms of the period. So my letter B will still be 1. All right, in terms of my amplitude, right, my midline looks like the middle of the wave is this line here, which is y equals 2. All right, and so that means I do have a vertical shift of 2 units up. But in terms of counting, right, if I count how far up and down from there, I'm counting 1 unit up, 1 unit down. So my amplitude is just 1. And I don't see any shifting left or right because, as I said, we're starting at the origin, but it's just been shifted 2 units up. So it really looks like there's only one change between this and the parent function, and that is going to be the fact that there's a vertical shift. So the answer is just sine of x plus 2. They will not all be this simple. Okay, let's try this one. This one is much more challenging. So let's try this. So there's a lot of things you can do at first. It's up to you on how you want to do it. I like to do personally is find the midline. So if I find the middle of the wave, looks like it's right here, which is y equals 4. So that tells me my letter D is going to be 4. My vertical shift is 4 units up. Then personally, I do the period. But again, it's up to you on how you want to do it. So I'm starting right here is on the wave. So that's 1, 4. If I go up and then down and then back up, I'm finishing at 11. So I'm just counting, how far does it take? How long does it take for me to finish a full cycle? That's going from 1 to 11. So what's 11 minus 1? It's 10. So the period is 10. To find letter B, it's 2 pi divided by the period. So in this case, it's 2 pi divided by 10. So if I reduce 2/10, I get pi over 5. So this is my letter B. So I've got letter B, I've got letter D. Let's try to find any horizontal shift. All right, looks like if this were not being shifted, right, I would be starting at 0, 4. But it looks like I'm starting at 1, 4. So that's a shift of 1 unit to the right. So my letter C, and again, I'm just going to write C. I know the notes have said C over B, but it's just going to be 1 unit to the right. So I'll put that in parentheses. So 1 unit right, which is a positive, right? You got to think opposite when you do this. Okay, and then what do I need left? Oh, the amplitude, my A. All right, so my amplitude is going to be absolute value of A, which it looks like from the midline I'm going 1, 2, 3. So I'll do that 1, 2, 3, 4 units up, and 1, 2, 3, 4 units down. So my absolute value of A is going to be 4. And so I'm going to write A is 4, and then I always tell students to check this last thing before we finish. So let's finish by writing f of x equals, so we'll do 4 sine, do my letter B, which we said was pi over 5, times x, think opposite here, minus 1, that's my horizontal shift, 1 unit to the right, And then my vertical shift, my letter D, was up 4 units. Now the very last thing I check is, I'll do that sketch again. So I'm doing sine here, right, sine of x, which looks like this, where it goes up, then back down, and then back up. So like this. Does it match that? Let's sketch it. I can just do orange. So here's what I'm saying. Does this in orange match what I just sketched? And the answer is it does, right? It's not perfect, right? But in terms of does it go up and then down and then back up, it does. So that the reason I bring that up is because that is going to be a positive for A. Okay. Now if, and again, this is just an if, and we'll definitely do many like this, but if it had gone down, then back up, then back down, that would not look like this, right? That would look different than my original. So that all that would mean is that instead of this plus, you would have a negative at the very front. But don't worry about that. We're going to do many, many, many practice problems to get to that level. Okay? All right, let's keep going. Now, we're going to finish this off. I know it's a lot going on here by doing some graphing. All right, so let's identify as much as we can, and then I'm going to do my best to show you how I use my algebra skills and then also the skills of Desmos to help me graph this. But you'll notice I don't just type it in straight away. So the first thing I do is I'm going to factor out, or I guess just take out, that pi over 2. All right, so if I take out that pi over 2 and put it in front, that is my letter B, right? That's my letter B. That's going to help me find the period. 2 pi over b. So that's going to be 2 pi divided by pi over 2, which is 2 pi over 1 divided by pi over 2, which is 2 pi over 1 times 2 over pi. So the pi's cross out, and I get 2 times 2, which is 4. All right? That shouldn't surprise you in terms of no more pi, because if letter B has a pi, as I mentioned, then the period will not. Okay, let's find the amplitude. All right, the amplitude is the absolute value of A, which is the absolute value of negative 2, which is 2. So we're going to be going up and down from our midline 2 units. Now, I don't see any, if you notice, let me kind of use a different color here. I don't see any x minus or x plus something. I don't see any plus or minus numbers after parentheses. So I don't have any horizontal or vertical shifts. So no horizontal or vertical shifts. So that's nice. So the very last thing I do before I start graphing points is I'm going to be strategic about the points that I plug in, because I don't really want to be graphing, that much in terms of decimals if I don't have to, if I can avoid it. So if I'm not doing any vertical or horizontal shifts, that means my x value is going to be 0 to start. I know my 1 period is 4 units, right? So we finish a full cycle in 4 units. So write that down as that last number. To find the numbers in between, you take your period and divide by 4. I know it's just a coincidence that it's the same as my actual period, but it will always be whatever your period is divided by 4. So 4 divided by 4 is 1. So that's going to give me my other points to plug in. So now what I do is I go to my graphing calculator, type this in, and then I strategically tell it which x values I want it to plot. So I'm going to type negative 2 times the sine of pi over 2 times x. So negative 2 times the sine of pi over 2 times x. All right. Make a table. So copy it, make a table. And I am trying to do 0 through 4. 0, 1, 2, 3, and 4. I'll do that. So let's move this here so you can see everything. Okay, so again, we're starting at 0, 0. We're going to 1, negative 2, 2, 0, 3, 2, and then 4, 0. Notice in that instance, it's taking me 4 units to finish a full cycle. I will also mention, as I mentioned in the previous problem, see how there's a negative at the very beginning? So my amplitude is 2, right? It's 2 units to get from the midline to the top and bottom. But because of that negative, you'll notice we're not going down to start. Or sorry, we're not going up to start like we normally would. So if I took out and put the positive, you'll see that it's going to go up to start. But it's not. It's negative, so we got to go down to start. All right, so let's fill in those table of values. 0, negative 2. So we have 0, Negative 2, 0, 2, and 0. Just confirm. 0, negative 2, 0, 2, 0. Excellent. All right, so here we go. 0, 0, 1, negative 2, 2, 0, 3, 2, and 4, 0. And you might be thinking, Mr. Vrandrick, why can't I just type this in and then sketch it? And I totally get that, right? But here's the thing. If you don't take the time to figure out this table, right? If you don't take the time to figure out these specific x values, you're going to probably have trouble figuring out where the graph's going to end up. All right, because there's going to be a lot of decimals, it's going to be a little confused. So that's why I take the time, follow the steps that I've done, and then we'll tell Desmos which x values we want to use. Okay? All right. So I'm actually going to skip this one. It's very, very similar, but it's got this idea of the 0.8 in front, and all that's just going to do is my period, because a b is 2, my period is going to be shorter, so it's going to finish the cycle quicker. And because it has 0.8, it's not going to go as high. And again, that negative means it's going to start reflected. All right, but I'm going to ignore that one for now. I'm not really going to give you decimals for letter A, so don't need to worry about that. So let's do these last two. I think there's 2 left. Yes, there's 2 left, and then I'll be done. All right, I'm going to factor again because I can. So y equals 3 times the sine of, take out the pi over 4. It's going to be x minus 1. Again, if you are worried about that, just make sure to re-multiply and see if you get the same stuff. Okay, I think it'll be worth your time to do the factoring if they give a problem like this. Thing I noticed, there's no d, right? We're not having plus 0 or plus 6, minus 2, whatever. So there's no vertical shift. Let's do the period. 2 pi over b, which is 2 pi over 4, which is the same as 2 pi over 1 times 4 over pi. The pi's cross out, and we get 8. All right, so then I'm going to have my amplitude, which is the absolute value of A, absolute value of 3, which is 3, and my horizontal shift, thinking opposite here, is 1 unit to the right. So I always make my table now. Normally, I would say we'd start at 0, but because we're shifting 1 unit to the right, I'm going to start at 1. My period is 8, so don't write 8. You got to add 8. What's 1 plus 8? It's 9. And then like I did before, I do my period divided by 4, so 8 divided by 4, which is 2, and that's going to give me my increment for the rest of my x values. So 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. That's how I find that. And I know I'm going pretty quickly, but we'll make sure that you go over it in class a lot. So let's go to Desmos, and let's type in this trig function with sine. We're going to do, I'm going to do 3, let's delete all these. 3 times the sine, I think it's pi over 4, times x minus 1. Let me just confirm. Sure, so 3 sine pi over 4 x minus 1. Great. I want to tell it which ones to use, so let's make a table. I'm using 1 through 9, counting by 2. So 1, 3, 5, 7, 9. All right, and then we zoom fit. There it is. So 1, 3, 5, 7, 9. Okay, so it kind of looks very similar to our original one. You notice we've shifted 1 unit to the right. Our period is different, right? We don't have a period with radians. This has whole numbers. We will do some that have radian periods at some point. All right, and we're going up and down 3 units because of our amplitude. So let's write down those numbers. 0, 3, 0, negative 3, and 0. So we got 0, 3, 0, negative 3, and 0. Confirm. 0, 3, 0. Excellent. So let's plot those. So 1, 0, 3, 3, 5, 0, 7, negative 3, and finally 9, 0. And there is our curve. Okay. All right, let's move on to the last one, then we'll be done. All right, so we've got cosine here. Do some factoring out again. So I have y equals negative 2 times the cosine. Factor out the pi over 2 that's in front of the x. When you do that, you get pi divided by pi over 2, which is going to be pi times 2 over pi. So the pi's are going to cross out, and you're going to get 2. All right, plus 3. Confirm if you need to. I'll do the confirmation right in my head. That's pi over 2x, and then 2 pi over 2 is just 1 pi. All right, so notice I've got everything here. I have a new period because I have a letter B. Let me write my letters here. So A, B, C, and D. So I have a new period because I have a letter B that's not 1. I have my amplitude is going to be positive 2, so I have a different A. I have a horizontal shift because of that plus 2 in the parentheses, and I have a vertical shift because of that plus 3. So we have a lot going on here. So let's start with the amplitude. All right, and I don't care the order which you do this. So the absolute value of negative 2 is 2, so that's the amplitude. My new period will be 2 pi over 2, which is 2 pi 2 pi over 1 times 2 over pi. So that's going to be 4, which we had previously. Our horizontal shift, think opposite here is going to be 2 units left. And then my vertical shift is going to be 3 units up. All right, so before I even get to the graphing, I'll put my midline on here, which is y equals 3. You don't have to do this. This is just for my brain to make sure I know how to do it. Then I'm going to do my x and y table, thinking my period of 4 divided by 4, which is 1. So now be careful here. We are moving 2 units to the left. So instead of starting at 0, I'm starting at negative 2. So a negative 2 plus 4 would be positive 2, and I'm counting by 1s. All right, so I'm going to go into my calculator to make sure I know what those y values are going to be. All right, so I'm going to type in negative 2 cosine of pi over 2 times x plus 2 plus 3. X plus 2 plus 3. And let me get rid of those parentheses now. And then we should be good to make our table of negative 2. Oh, look at that. It's already there. Boom. We can zoom on up if you want. Okay. So notice, you don't have to put this, but if you put that y equals 3, that's that midline. The amplitude is going to be 2 units, right? The absolute value of negative 2 is 2. My first point is down here, and here are my 5 points to plot. All right, I'll try my best to show you why it's kind of starting there and not how we did cosine at the very beginning. All right, so let's do 1, 3, 5, 3, 1. There it is. 1, 3, 5, 3, 1. Here we go. So negative 2, positive 1. Negative 1, positive 3. 0, 5. 1, 3. And finally 2, 1. So it looks like this. So you notice the period is a little bit different, right? Because it is a whole number, right? But remember, when we did cosine for the very first time, right? Cosine started at 0, 1. It went down, and then it went back up, right? Like this. This is what cosine looks like. So if you look at what we graphed, you're like, whoa, that doesn't look like it. But that's because it's been reflected, right? This negative at the very beginning, because A has a negative, that means it's going to start, instead of starting at like 0, 1, I'll show you a quick sketch here, right? The negative cosine of x means you're going to start at 0, negative 1. So it end up looking like this for the negative cosine. So just keep that in mind, and we'll practice that a ton, that if you have that negative, it is going to change something because of that reflection. All right, so that's it for this. Make sure you come see me if you have any questions, and good luck on the links.